All right, hey crew, we've been chatting for a bit, but I'm beginning to talk about like what we're going to talk about tonight. So I figured I'd start the recording. Tonight's an interesting one for us, and it's interesting for two reasons. One, I actually suspect we're not going to get through all the material tonight because it's a lot, and it's probably some of the densest material we're going to cover in this whole course. And just from, I can tell you just from the fall, when we taught this, we ended up breaking this material into 2 weeks just because it was a lot. Um, and I sort of suspect we're going to go that way tonight. So that's going to be the first thing I'm going to just note with this. And it's one of those things where, again, the code itself isn't that hard, but we're going to go pretty deep into some topics that you didn't really even think you needed to go deep on, and we're going to go deep on them. Um, and I think it's gonna be cool. I think we're gonna end up in a cool place, but we're gonna have to kind of we're gonna have to do some digging to get there. Is gonna be the first thing. The second thing is there is going to be a um, sort of a consistent theme that we're going to begin to see in this course. And and we're just going to begin to scratch the surface now. And it's part of the drawback of working in Python. Now, I think the advantages at this point are fairly obvious, fairly self-intuitive. I mean, you guys have been doing Python for a bit now, so you're hopefully pretty comfortable with it. Hopefully, you're pretty sold on like the upside of Python, which is, it's very robust, very functional, very very laid back syntactically. Um, Plug and play mentality. Um, there's a lot going for it from a developer standpoint. It's a very developer friendly, but there are some major drawbacks to it. And maybe not necessarily the biggest. I'd say probably still the biggest is compilable versus interpreted code. I think that's probably still the biggest drawback of Python. But um, beyond that, I would say what we're going to begin to see tonight, and we're going to begin to see in things, is have you guys heard the expression "jack of all trades, master of none"? Is that an expression, a turn of phrase y'all have heard before? Okay, cool. Generally, it seems like folks are kind of familiar with that. But the idea is kind of basically something that does everything, but precisely because it does everything, it doesn't necessarily do any one thing exceptionally well. And I think if you have to indict Python for something, that might be it. Um, Again, the whole run compiled versus interpreted, that's another sort of big thing. But I would say generally speaking, this jack of all trades, master of none is kind of a prevailing theme, and it's one that we're going to begin to see tonight. And into next week and in future modules, we're going to see it in further detail. But um, precisely because Python does literally everything, it doesn't always necessarily do it particularly well. And particularly when you compare it with other programming languages and platforms that are really optimized for particular sort of use cases and functionality, um, Python just feels kind of awkward and in many ways feels kind of forced. Um, and yeah, and so we're going to see again, just kind of setting the stage. I haven't really given you enough context to be able to understand that. But I think in terms of the material we're going to cover tonight, that should hopefully become pretty apparent, uh, why we're going to begin to say. And again, we're going to see this over and over again. Like we're going to see this, for instance, like when we do graphical user interfaces. Like you can totally do front-end development in Python. Is it as good as some other languages? Obviously not, right? But you can do it. Again, same idea, right? Jack of all trades, master of none. Um, all right, so let's see here. Where are we? This is us. Okay, so we are going to talk about tonight. So there's a few sort of topics that we're going to key up, and we're going to spend a lot of time talking about, of all things, the function, the humble function, right? Remember how last week we spent an inordinate amount of time um, on variables and assignments and binding, and you were like, "This is chapter 2 stuff. What are we doing here?" Well, now we're going to do chapter 6 stuff. We're going to go deep on functions in a way and we're going to think about it in a way that we haven't really thought about before. And That's going to lead up to us learning about a concept called decorators. And we're going to learn about decorators. And the reason we're going to learn about decorators is ultimately, we're going to say, like, why are we talking about functional programming? Why are we talking about things called decorators in the context of an object-oriented programming discussion? Well, because of this technically second bullet point, but I guess third bullet point here, static and class methods. Because what we want to talk about is methods that are methods within a class that are not bound to the object, but rather bound to the class. That maybe doesn't mean a whole lot now, but we're getting there. And we have to see how Python does it. And again, it's going to be one of those things where it just doesn't really, we have to kind of use this little decorator thing to kind of make it work. Other programming languages, again, just by comparison, Java, for instance, it's just kind of baked in. Um, so yeah, but I think this is where we're at. Then finally, assuming we can get there, and I think honestly that like that's going to be the class today. I have a suspicion we're not really going to push much beyond that tonight. Um, we're going to then talk about the last topic we need to cover in object-oriented programming is encapsulation. Ooh, another fancy little term here. And again, we're going to sort of see here, return to that theme. A lot of other programming languages sort of do encapsulation and do it very well. Python doesn't. Python really doesn't do it at all. And so we're gonna learn it, but then we're gonna see like actually it's more of like a naming convention than an actual thing in Python. So yeah, it's kind of one of those. It's good to know, and definitely if you take other object-oriented programming languages, it'll be very useful. Python, it's more of like a suggested approach. So that's our plan, folks. All right, let me pause, take stock. How you guys feeling? Any questions before we dive in? All right, you guys ready to rumble? All right. So we're gonna talk decorators. Okay, so first again, um we're going to sort of set the stage because remember how I mentioned to you that the whole reason we're talking functional programming, the whole reason we're talking about uh, um, yeah, decorators in the context of object-oriented programming is we want to talk about class level methods. And so, oh, actually, no, sorry, well, sorry, yeah. So the point is sorry, that was not what that first bullet point was getting to. But just to, again, finish that thought, again, we're getting at with this is ultimately we're going to, just to keep in the back of your head, we're going to use these decorators to create class level methods. We're not there yet. We're going to get there. That is the walk. That's the journey you and I are going to go on tonight. Okay. So, but let's kind of start that conversation now. So last week we talked about inheritance and polymorphism. So you may remember, right? Inheritance was this idea that again we have a parent class and then we have a descendant class and our child class, and we could essentially pass all of the sort of relevant stuff in there to that, and then with um, polymorphism and not God, what is it? Not inheritance, but why am I blanking on this? Enhancement? But the idea being that we could sort of take, oh, extension. Sorry. We could take, right, a class, create a child class, inherit all the functionality from that parent class, and then extend its functionality, basically layer over that. And now the question is, could we do something similar with a function? Could we have a parent function, if you will, that we can sort of then maybe kind of inherit or pass through or do something to it that we could then sort of expand its functionality. We could extend its functionality, much like we're able to do with functional program or with class programming, right? So that's kind of the basic concept. Can we take functions and can we, through sort of a similar process, expand and enhance their functionality? And the short answer is yes, of course we can. And that's the whole idea of decorators. So decorators. So I'm going to read this thing here. I'm going to read this line here. It's not going to make much sense right now. And that's okay. We are going to, this is the journey we're going to walk. But I'm going to read this sentence right now It's not going to make any sense. We're going to come back to this after we've gone our thing, and hopefully when we come back to it, it's going to make sense. But let me just read it to you up front. Decorators allow us to wrap another function in order to extend the behavior of the wrapped function without permanently modifying it. Okay, that's again not going to make a lot of sense now. We're going to put the old pin on that. We're going to come back to that. Before we understand what that is, the first thing we have to note is that remember how we've said from the beginning, Python is an object-oriented language, right? But unlike other object-oriented languages, it doesn't sort of hit you over the head with it, right? It's never as explicit. You can explicitly work with classes in Python, but you don't need to. It's not like Java where everything needs to be embroiled within a class definition. You can't even write a basic program without it being in a class. Like there's, it's not, it doesn't hit you in the face with it. It's subtle. And in fact, when you learned intro to Python, you went almost 3 months before your teacher, if it was me, some jerk was like, oh yeah, by the way, everything is object-oriented programming, right? So it's very subtle. But the thing is, even though it's subtle, it doesn't mean it's any less prevalent. And what I mean by that is in Python, everything is ultimately within a class object system. Everything. Nothing, no part of Python is not a class object dynamic, right? And we've talked about the idea that, again, basic things, strings, lists, dictionaries, integers, booleans, right? These are all objects of particular types, particular classes. But what we haven't necessarily fully explored is the idea that if I tell you everything in Python is an object, it really is. And specifically, even functional code is an object as well. And in fact, functions are simply objects of the base Python object type. I say, huh? But good, another way to wrap function. Yeah, America, we're getting there. We're getting there. Sorry. Or believe me, we got to walk a bit before we get there. So you might say, okay, well, what does that matter? Well, here's some key bullet points that matter if we understand that functions themselves aren't just blocks of code. They are themselves objects. And if they are objects, there are certain things about objects that we can do because they are objects. Because again, they're not just abstract code, they exist as an object within the Python program. Specifically, what can we do with any sort of object is we can store it, right? We can assign or we can bind a variable to an object. So it turns out we can do the exact same thing for a function. We can bind or assign a variable to it. Furthermore, anything that you can do for objects, right? You can pass them in as a parameter to a function. And it turns out you can do the exact same thing for functions. You can pass in functions, not just the outputs of a function, but the function itself, because it is an object, it can be passed in as an input to another function. In a similar vein, just like you can output any return, right? You can return any object in Python. It can be a dictionary, a tuple, a list, a thing. Turns out a function itself can be a return. And then finally, you can store, right, because it is an object as a discrete sort of value, it can be stored in data structures. So hash tables, lists, you can sort of assign them to any sort of data structure to work in. And these are all results of these, again, functions being themselves objects within Python. Okay, let's see what we mean by that. So the first thing to note is that, yeah, again, so I'm not going to do this. All right, so I'm going to sort of we're going to begin to break this out a little bit. So a function decorator. So what is a function decorator? Fundamentally, it is itself a function that takes in another function as an argument. So it's an input parameter to this function is another function that then extends that decorated function's functionality without changing its structure. So in other words, again, we're abstract, believe me, we're still working through what exactly this means. But essentially, this decorator function is going to wrap another function. It's going to take that existing function. It's not going to change its core behavior. It's going to take that function and it's going to amplify and extend its function. Okay? So let's see kind of how we get there. So first thing to remember is because a function is an object, it can be assigned another variable, right? And that's what you see here in this example here. In this case, I've created a function greet. It's a very rudimentary function. It just prints a string, hello, John. And then you're going to notice here, I do a variable assignment. I set the greet underscore John variable as equal to greet. Then if I execute greet John, right? And we execute, right? We execute rather than just kind of returning the code or referencing the code, we execute the code by appending the pair of parentheses. If I execute greet John, you'll see it executes the original greet code, source code. So it outputs hello John. So again, variable, right? First idea, because a function is itself an object, we can assign a variable to it. And because we can assign a variable to it, we can reference and execute that variable as well. Okay, so that's the first sort of note there. The second thing we said is that, remember, because a function is itself an object, it can be itself returned as the product of another function. So let's take a look at what's happening in the second example here. So again, I'm still defining the greet function, but you'll see what I do with inside it is I'm defining a brand new function here, greeting at dawn. You're going to see here, it prints good morning. And then you'll notice here my return to the overall greet is I return this greeting at dawn. So this function itself is the output, the return of this function here. And then you'll see here, I do a variable assignment here. So in this case, I say salute and salute. One interesting sort of slight notation here is I'm actually executing the greet function here. I think it can be done interchangeably. It's worth testing though, if that's the case, but I think it can be done interchangeably. But salute is then variable assignment. I then run salute itself. It then pass through. It then returns this function and executes it. So I think we do need actually that second execution. The running of greet runs this and returns greeting at dawn. And then when I run, so salute will return greeting at dawn. I then need to run it again to then execute greeting at dawn and get my good morning. Okay, let me pause there. Y'all with me so far? Okay. So again, start with the idea, right? Again, conceptually, we have to get away from the mindset that say functions are just blocks of code to this idea that no, functions are themselves objects. And because they are objects, they have all of the sort of innate functionality that a Python object has, right? It is literally a entity that exists in a Python program. And because it exists, all of the characteristics we associate with an object, we associate with it. So again, being able to assign a variable, being an input parameter, being a return, right? All those things are elements that an object can do and that our functions can do as well. So in a similar vein, because functions are objects, they can be passed in as an argument or as a parameter for another function. So an example here, so let's see here this greet sum function here. So you're going to see here it takes in a function as input. And then you're going to see here, right, in this case, we print good morning and we have an end on same line parameter. And then it executes whatever the function parameter is that you passed in. And so then you'll see here, we also created a say name function. It just prints the word John. Then ultimately, I execute greet. I think there's a missing step in this thing because we should have done a variable assignment to greet sum. So that's probably not fully right. So this is actually going to be greet sum, not greet. But right, so greet sum, and you see I pass in say name as a parameter for it, and then it outputs good morning, John, right? Because it prints good morning, same line with a space, and then it executes this function. In this case, it's John. So again, functions themselves can be input parameters to other functions. All right, still with me? All right. Shriek into the void if not. Okay. Are we really still doing decorators? Oh, yes, we are still doing decorators. Okay. So let's look at what a decorator now that we have that baseline, right? Now that we understand those elements of functions, it gives us a baseline for understanding how a decorator could work. Okay. So a simple decorator function, it starts with a functional definition, which is the decorator function. So in this case, the decorator function is your overall sort of function doing the decorating. In this case, it's increase number. And then it creates a nested function within that outer wrapper function. So in this case, right, we create this nested function here. So increase number, and you're going to see here we create this nested function increase by 1. And ultimately what the decorator function is going to do is it takes in the function as input and it's going to return the nested function, right? So those two ideas there, it takes in a function, returns the nested function that it has created. And then we have the function that is being decorated. That's your source function here that ultimately is being returned here. So again, let's sort of see how this works. Um, in this case, this is our base function, get number. It just simply returns the number 5, okay? As rudimentary a function as you can imagine. We now have our decorator function, increase number. It takes in this. And you're going to see here now within our wrapped function, increase by 1. And you see it prints increasing number by 1. It defines the variable number plus 1. It executes that function in increments by 1. So in this case, it's going to execute that function, which will return 5. 5 plus 1 is 6. That becomes 6. It returns this overall function. Oh, sorry, returns that this function returns that variable. This decorator function returns the overall function increased by 1, the wrapper function. And then I'm going to see here, I sort of define the result of this as a variable. I say increase number, right? My decorator function, I pass in get number, execute that code, right? I execute this code and print it. You're going to see here incrementing by 1, and we get 6. That is the basic idea of a decorator function. So again, just to kind of recap, using the syntax that we already have, you define an outer function, which we call the decorator function, that takes a function parameter as its argument. You then nest a wrapper function within the decorator function, and that wrapper function is what the decorator returns. Okay. And then this wrapper function, as part of sort of doing it, will take the function and will extend its functionality. Typically, it will trigger, it'll execute the function that was read in, and then in addition, it'll do whatever else it wants, whatever you're sort of decorating or extending it with. And then ultimately, you have the decorated function, the function that is being decorated. All right. So far, so good? Again, the logic can be a bit tricky to 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 sort of follow. So that's why I sort of want to emphasize those points here and make sure we're sort of understanding this block here. Because hopefully this is syntax we're familiar with, and hopefully this sort of logically extends from where we've sort of been already. So are you guys all good on this line here, on this code block here? All right. Anybody struggling? Anybody want me to talk it over, or are you guys all good? Oh, you guys want to see if you guys want me to make it a little bigger? Let me see if I can make it bigger. There we go. All right, there's our code. Okay. Hopefully that helps. Okay. We're good so far? All right. Now that we have this, we can actually sort of make a more concise version of this, which is the same basic idea. So these are actually going to be the same. These are the same code blocks, the same functions. It's just a more concise representation of it. In this case, we still have our wrapper function, which is our decorator function. We still have increased numbers. We have the wrapper function increased by one. You see it, the decorator takes in function, still executes the function as part of the wrapper function, still returns the wrapper function. We still have our decorated function, get number, but you will notice here, there's a interesting notation here. There is the at symbol, at increased number. And when we do this, when we do the at increased number, we are essentially just a shorthand way of saying, I am decorating get number. And then two interesting things come from that. The first thing is, so you may remember when we then wanted to get this decorated functionality in the original notation, we had to call the decorator function. We had to call increase number and then explicitly pass get number into it, right? In order to then get that decorated functionality. Here, look what happens. We don't call increase number, we call get number itself. We call the source function. And because that source function is now decorated, it will return the complete functionality. So again, we sort of use this mechanic here and our ability to sort of pass in function do that to say once we decorated a function, once get number is decorated, all we have to do is call the original function get number and all the associated decoration will sort of be executed as part of it being decorated now. And by the way, another interesting sort of thing that potentially comes out of this is you can potentially use the same decorator for multiple decorated functions. I don't necessarily know that you would need to, but if for whatever reason, let's say you had multiple get number implementations, you had, let's say, get one, get two, get three, get four, get five, you could simply just decorate each of them and then just kind of invoke them using the same, just, get one, get two, get three, and they'd all be decorated in the same manner. All right. Questions on that? You guys get?
Okay.
Oh yeah, please go ahead.
Yeah. Yeah, it's I can follow the implementation,
Mhm.
but it's like from in my perspective, it's like I don't know the benefit of it because it's like it's being redundant.
Yeah. Yes. So it's a good question, right? Why is this useful? And so the reason this is potentially useful, and we will see a precise example of this when we get back to classes and object-oriented programming. There are times when you, um, so yeah, actually, so Berland, rather than talk to you in abstract, if you wouldn't mind holding on that question, because
Okay. Yeah,
it's a great
it's
question.
okay.
But
Mm.
when we see it applied to class and static methods, I hope it will be clear why the utility of doing something like this.
It's okay. Thank you, Prof.
So no, I appreciate that because it is a really great thing. So I mean, how many decorators you can assign to it? So I mean, yeah, that's a great question. I'm not aware of any nesting of decorators using this particular functionality. If you use this original thing, you could theoretically pass in, right? You could sort of do multiple layers to it if you do it in the original way. I don't know using this sort of compressed notation if you can sort of do multiple tiers of it. So in that instance, you may have to be explicit where you're sort of passing in functions to others, getting those as outputs, passing them in. If you use this notation, there's no meaningful, I think, limitation to it. But yeah, I'm not aware of an ability to do sort of multiple layers of that. So but that is a great question. Yeah, great question so far. Any other questions? All right, ready to ready to press on. Think we're done with decorators. We're not done yet. I want to teach you guys. Are you guys familiar with args and quargs? One of my favorite topics to talk about, just because I get to say arg and quarg for 20 minutes. So, anybody heard or seen args or quargs? Okay, literally args and quargs, just right here on the slide. Okay, I'm going to take that as a no. Okay, you may have seen it. This might be something that you've seen before. So here's a fascinating idea. Um, in the intro to Python class, we had this interesting topic where sometimes we would have inputs of varying length, right? We would have a varying number of numbers, for instance, that would be input, something like that. Um, and we, and the way we handled that was we took advantage at the time of strings, right? We said strings you can be flexible, right? I mean, up to a certain point, right? Strings can be, you can take in any number of numbers just as a string, and then once you have it, you can partition it into a list and then do whatever type conversions, whatever things you need to do with it. Um, so that was one way to do it. What we didn't know at the time was actually Python has a really, really simple way for taking in a flexible amount of inputs. And that is this args keyword. So args allows us to take in a flexible amount of inputs. It basically says, I don't know how many inputs the person's going to put in. I don't know, you know, what they're going to look like, things like that. All I know is I'm open to taking any number of inputs. And what I'm going to then do is whatever the amount of inputs is that the person puts in, I'm going to then take the result and automatically convert it into a tuple data structure. So whatever, again, however many things the person puts in, I'm just going to take those, stick them into a tuple, and then within the body of the function, you can do whatever you want with that tuple. So just as an example. So here is a sum numbers function, right? So we want to be able to sum a flexible amount of numbers. So in this case, you're going to see here, so it starts a counter at 0, and then it loops through the argument's tuple, and then increments and adds that particular number to the total, and then before returning the overall total. Right? And so you're going to see here, if we execute this and we say, okay, 1, 2, and 3, the first thing it'll do is it will convert that into a tuple with 1, 2, and 3 as number inputs, numeric inputs. And you're going to see here, because the inputs themselves are integers, it does two things that, right, it streamlines two things. The first is we don't have to explicitly strip. We don't have to explicitly split. Sorry, not strip. Split. Strip is a different thing. We don't have to explicitly strip the string. It automatically converts, it automatically takes every comma delineation and creates a new sort of index position in a tuple data structure. That's the first thing. The second thing is it doesn't assume a data type. Right? It doesn't automatically convert everything to just a list of strings so that we then have to do some kind of like, list comprehension to convert it to a list of integers and things like that, right? If you input um, integers, it'll keep them as integers, right? It'll just sort of automatically create a tuple for you like that. Again, same thing with the second example, 5, 10, 15, 20. Again, it will create a tuple with those four numbers. And then when you loop through them and add them together, it'll give you 50, right? So very kind of cool idea there. Cool way of, again, being able to take in flexible inputs. Any question on args? See, I love it. We're getting piratey tonight. Arg. Just give me any excuse to just keep talking about args for 20 minutes. Are you still with me? You're arging it up? Quargs are just like args, but they're for dictionary assignments. Yeah, pirate symbol in the chat. So here, and you can just, again, here, you could just sort of see the example, and I think it really sort of helps to highlight it. You would just define a key pair value directly as in the input string, right? So in this case, name John, age 30, city, New York. It'll create a dictionary data structure with the name key value John, name key, the the key of name, the key of age, and the key of city, and then the values of John 30 in New York. And then you can see here, right? In this case, I can then, I can loop through, right? Remember dictionary has the items method that allows you to return both key and value. And so I can just print the key and the value. So I'll put name John, age 30, city New York. So again, kwargs are the same idea, but instead of just taking the value itself and storing it as a tuple, it takes the key value relationship and creates a dictionary for you. See, isn't that cool? I know it's one of those things that's like really like you see it and it can be like a little bit intimidating, but when you actually like learn about it, you're like, wow, like that's pretty neat. Like that we kind of have that functionality and we just didn't know about it. But yeah, I think it's cool. Oh, folks, good news. I think someone's joining us. Come on in, buddy. Are you coming in to say hi to everybody? Coming in to say hi to everybody?
Is that Spider-Man?
Oh no, Spider-Man's not here tonight. Oh, I'm sorry.
Oh, Batman.
Yeah, Batman's not here tonight.
Well, we have from my baby shark ball.
Your baby shark ball?
Yeah.
Which baby shark ball? This one?
Not that one, the baby shark one.
The one at the toy store?
Yeah.
Oh, we can go to the toy store this weekend.
Daddy
No,
won the baby shark one.
baby shark ball. Oh, don't you have your bag of balls downstairs, don't you?
But I lost that one.
You lost that one. Oh, I didn't know we lost it. Okay, we'll take a look for it. In the meantime, do you want to wish good night to everybody? You want to wish good night to everybody? Wish them a big good night? They've been stuck listening to Dada talk for an hour. For them. Terrible. I know. So miserable having to deal with me. Do you want to say good night to them and then close the door? And but I think I'm going to take a break soon, so I can come in. I can come in and wish you good night.
Then can I go down with you?
No, you want to just stay up here for a little bit, for a minute or two?
Yeah.
Oh, Savannah, look who's on the screen.
Like,
Baby Shark came on the screen. That's awesome. Thank you, guys. All right, but Savannah, you can stay with me for a minute, but you have to be quiet because Dinah's finishing up a topic. Can you do that?
yeah.
Okay. All right. Everyone's saying hi to you, by the way.
Dada,
Yes.
and you scroll. Why scroll the whole thing?
The whole thing. No, there's a lot of people talking, so it's just the last part there. So okay. So as you guys might have noticed, we are almost done with this. I want to apply this. So I want. Oh, you got your princess shoes on. Oh, that's awesome. Okay, buddy, gotta let Donna finish this. Gotta let Donna finish this. I'm gonna take you down. Okay, last slide on decorators. And believe me, if you feel terrible reading this, imagine how I felt writing all this out. So, this is the last thing I wanted to say about decorators, and then again we'll take a break, and then we'll bring it back and we'll apply it all to. Ooh, careful, yes, buddy, yes, but you gotta let Donna talk now. Gotta let Donna talk. All right. So in this case, we can use that arg and kwarg thing to dynamically extend the functionality of decorators. All right, because up until this point, right, up as all these examples that we've done here, we have just executed functions directly. We haven't taken in inputs and we haven't taken in flexible inputs either. So we have the ability here to, and this is sort of an interesting thing because one thing that I didn't specify, one thing that I didn't really explain very well is why do we need this wrapper function, right? Why can't I just take in a function, execute all the code I want, and then just return the result? What is the need for this wrapper function with nested function within the decorator? And the reason we need that is because the wrapper function is what enables us to take in multiple inputs to them. I said she could be here as long as she's quiet. So that's okay, because I'm almost done. Oh, okay, sorry. No, Savannah, honey, you need to go downstairs, okay? I'll be there in a couple minutes. Okay. So so in this instance, so let's sort of take a look at how this sort of plays out, because not only can the wrapper function itself take direct inputs, but well, actually, let me do this first, and then let me extend this by talking about args and kwargs. So let's look at this example here. So here we have our base function here. Multiply two given numbers, takes in two numbers as inputs, right? Number one, number two, and then returns a formatted string, which is just number 1 times number 2 equals, and then the product of the two of them multiplied together, right? So that's our base function here. The decorator function here takes that function in, but takes in those parameters here, and you're going to see here it extends, it decorates it by adding this little string here. We're multiplying two numbers, and then there's sort of, I had to cut off that for spacing, but it basically gives you that, and then returns the result of this function with those two numbers passed into it. Right? And so then the overall decorator returns that. So again, so now if you do multiply two given number, once it's decorated, you multiply those two numbers, it will give you this. It'll give you the decorated functionality. We're multiplying two numbers, 3 and 4, and then the result of it. So that's going to be sort of the first thing. The second thing to note here is that we can use args and quargs in our little wrapper function here to potentially make the decorator function more robust. So for instance, in this case, our little decorator here is putting in specific parameters. It's putting in a couple arguments, putting up a couple keyword arguments. That's being decorated, and it's being able to sort of process it because it's being flexible in terms of its inputs. Okay, so I know that got a little bit chaotic there, but key things to note with this. Again, first one is, one thing we hadn't explored up to this point is this idea that not only can I pass in a function, but by having the wrapper function and returning that wrapper function, it gives me the ability to take in parameters, input parameters, that can modify the function being decorated. So that's the first thing. The second thing is we can extend the wrapper function's functionality by making it agnostic to the number and type of inputs it takes by sort of replacing fixed input parameters with, again, these args and quargs. So kind of an interesting sort of thing to say for that. All right. How are we feeling about all that? I know it's a lot. We're going into a break, as you might have
Can
imagined.
I confirm what I understand?
Please, Berlin.
Yeah. So it's like the one that is being decorated is the function that is passed, that is what's that? Yeah, but the first thing that no, no, I'm
Yep.
confused.
No. Let me
Yeah,
here. Let me try to like annotate this.
what I understand right now is the one that is being decorated is the function that is being passed on the decorated function. I don't know.
Yes, pretty much.
Mhm.
So okay, so here, hopefully this will help because I know the verbiage can be a little weird. The function that is being decorated ultimately is in this case it's this one.
Okay,
It's
yeah.
multiply two
Okay.
given numbers.
The first thing that I understand is the one that is under the wrapper. I thought the wrapper is the multiplier numbers.
Hmm.
Yeah, that's the first thing that but because of this example, the one that is decorated is the one that is passed on the decorator.
Exactly. Yes, exactly. It's the decorated function that gets passed into the decorator, and then within the decorator, the wrapper function extends the decorated function. Yes.
Okay. Yeah, thank you.
No, I'm glad you guys asked. All right. And believe me, this is a lot, and I fully grant that this is we had to do a lot to get to this point. So, um, if you guys need to review it, if you need to sort of think through it, if you have any other questions, clarifying things, let me know. Um, all right. This is as good a time as any, I think, to take a break. When we come back, so we're done talking. So good news is we're done talking about decorators. What we have to do now is we're going to apply decorators to object-oriented programming. Now that we know that we have the ability to decorate certain functions, the interesting question is, can we use decorators to modify methods within a class? And long story short, yes. And this is how we're going to get class level methods and things like that. So, okay, let's just reconvene at 7:40 and And yeah, I'll we'll keep on keeping on. So we're done with decorators, or at least we're done with the concept of it. But I did want to mention, right? I did want to say, remember, we were going to um, go back. Because remember, I said this paragraph wasn't going to make much sense, but hopefully it's going to make more sense now. So now let's go back and let's review the language and make sure actually indeed, right? Now we're kind of here. We can sort of walk it back. So again, we say decorators are a very powerful tool in Python since it allows programmers to modify the behavior of a function or class. Specifically, decorators allow us to wrap another function in order to extend the behavior of a wrapped function without permanently modifying it. So now hopefully you can be like, oh yeah, that's exactly what decorators do, right? Hopefully, if we've done our job. But all right. Um, any questions on decorators before we move on? All right. So now what I want you to do is I want you to actually take uh put decorators. So now you have this concept, right? You have this notion, this ability that we have to take again, take the functionality of a function and extend it using this decorator notation, right? That was something we didn't know we could do, and now we know we can do it, right? Now you're gonna put that in your vault, your little vault of knowledge, and now we're going to talk about how we might apply that to object-oriented methods, programming methods. And so, um, specifically, what I want to introduce is the distinction between object level methods and class level methods. Because if you remember last week, we introduced the idea that attributes could be class level, right? Which is when we started out, we had, oh, sorry. Okay. Let me turn off my notifications. When we started out with classes, right, very simple, very basic thing. Attributes and methods were both assigned to the object, right? You would initialize the object here. Let me even just pull up our little example from last time. I'll reconnect. Okay. So you may remember, here's the thing that we were playing with last time. Okay, was this thing. We have this class here, right? We have a bunch of attributes and we have a bunch of methods. And both the attribute and the methods were assigned to the class or to the object, which means that, for instance, if you wanted to do define, you would have to create a player. You'd have to do like Munina or whoever the player was, and it'd have to be like Munina.define, right? Because the method was bound to the object. Same with the attribute, right? We didn't have attributes at the class level. We had attributes at the object level. So Munina.name, Munina.job, Munina.power. Then last week, we introduced the concept of class level attributes. So specifically in this case, we have a game. And game, in this case, is League of Legends. And the idea here that this variable belongs to this attribute belongs to all instances of the class. And specifically, it exists outside of the objects. The objects point to it. So you could have munina.game, right? You can have america.game, um, cindy.game, but right, it was a class level attribute. And remember, that's where we got into the whole conversation about bindings and assignments and all that fun stuff. This week, we're going to say, okay, well, if attributes can exist at a class level, what about methods? Can methods exist at a class level? Right? And specifically, oh, where's my notes for this? Can we potentially execute class level methods outside of any particular object that's bound to them? As it turns out, we can. We absolutely can. And there's sort of two types of class level methods. There's class and static methods. And by the way, when I mention again Python, right, the theme Python being master of all trades, jack of none. I'm sorry, the exact the exact opposite actually. Jack of all trades, master of none. Here's a good example of this. Other programming languages, other object-oriented programming languages do this naturally. Like again, just because I'm teaching Java concurrently, I can sort of speak to that. In Java, it's very easy, very trivial. You literally just do a static keyword and it becomes a static method that belongs to the class, right? It's not an object specific method. It's very easy, it's baked in. Python didn't have that functionality, it didn't have that capability. We had to um, we had to um, manufacture that ability. We literally had to sort of create and retrofit the ability to do class level methods in Python because it didn't exist just automatically. So so that's again when we talk about the fact that like again Python is kind of an awkward fit because it's things like this where it's because it worked so hard to be this nice easy little functional programming language that was somehow an object-oriented programming language. Some of these things kind of got sort of paved over for simplicity's sake, and then we kind of had to like reverse engineer certain capabilities that just natively exist in languages like Java. So, okay, so what is a class method? So again, a class method it belongs to the class rather than the specific object. And so because of that, because it belongs at the class level, it does not require that you create an object or a specific instance in order to then execute, right? So again, going back here, again, I could not, oh, sorry, wrong one. I could not execute define until I, first created that player. Yeah, I created the in player and then I could do in.define, right? I didn't have to do that here. I don't have to do that with a class level method because it's tethered to the class and the class already exists. Um, Classes are objects of the class method. It's a whole thing. Even classes themselves are in them of themselves objects. It's you get really like weird things going on in Python when you really get abstracted on these whole classes things, but classes themselves are objects, basically. And so because of that, once you have defined the class, you've defined the class method, you can sort of you can execute the thing directly. Now, generally speaking, when would we use, and so generally speaking, what's the distinction between static and class methods if they both exist at the class level? Generally speaking, a static method knows nothing about the class. It deals with none of the inherent attributes. It deals with nothing of things. It's just kind of an independent, what we call utility function. And we're going to see some specific examples of what I mean by that that'll help to clarify that. Class methods usually, generally speaking, work on the class itself. And there's sort of two particular there's two particular, for the most part, methods in which we'll use it. The first is what we call factory methods. Factory methods are methods that sort of modify the execution of a class object, like specifically modifying a constructor for different use cases. So again, thinking about like a factory method is saying like I have this class, right? Going back to our little metaphor, you have the little stamp that's doing it. A class method allows you to modify how something gets stamped out, basically. So that's a factory method. And then we also have potentially getters and setters on the class level, right? So much like we can modify object level attributes using object level methods, we can modify class level attributes using class level modifiers. Um, so let's kind of take a look and let's sort of see what that looks like here. So, so actually, sorry, let me uh, sort of walk through actually the notation for how to do this. In order to convert, because remember what I said, Python just doesn't do this out of the box. We had to sort of retrofit a way to do this. In order to do this, we actually had to use the class method functionality to convert um, methods within a class into class level methods. Okay, so you're going to see here. So in this case, let's just sort of take a look at this. We have a class student. We have a class level attribute marks. You notice there's no constructor. There's no self dot marks, right? It's just marks equals 0. So this student has a class level attribute here. I then define a compute marks. It references itself as obtained marks. And then I say whatever, okay, whatever the parameter that I pass in here, obtained marks is, I modify marks to be that. And then I print, right, my obtained marks or whatever the marks are. Now again, because this is just a normal method, I would have to create a student object normally in order to then manipulate that. But again, if I'm then creating a student object, I'm not necessarily modifying at the class level then. I'm modifying that particular student's pointer, right? And that's what we talked about last week. So I'm not going to be able to modify the class level attribute. So what I need to do then here is, as you can sort of see here, I call in the class method function, pass in this method here. That's what converts it into a class level attribute. And then when I invoke it, it's now doing a class level operation. Okay, so that's kind of the way I have to do it. So I have to decorate my function doing it. Um, and you can see here, we can also do the shorthand method, just like we did before, where we can just say class method here, right? I can just say within the definition of the class, I just define my, I define my method here. I just use the class method decorator, and that's what allows me to then convert that. And then you're going to see here, when I then invoke it, so you're going to see here, when I then invoke sorry, let me talk about the invocation in a moment. But that's generally how we get the wrapper. And then let me talk a little bit about what this example is doing, and I'll talk a little bit more about decorators in this context. So two things to note here. One, when I do this class method, when I use the class method decorator, you'll notice two things. The first thing is, instead of self being a parameter, right? Normally self was a parameter because it was an attribute. It was an object level attribute. Here you're going to notice here, instead the class itself becomes the attribute that's passed in. So that's going to be the first modification we make. So that's kind of a notable thing. Um, the second thing here is that this is a factory method. So if this here was a class level modifier, if we use this to modify a class attribute, this is an example of a factory method. So let's look at kind of how this works, right? So here we have a person class. It has a constructor. It has name and it has age as two sort of attributes for this. And you'll see here, I can initialize it, right? And then it has a object method display, right? That just prints the person's display. You're gonna see here, right? I can initialize an object, in this case, Adam, who's aged 19, and I can execute that code. But you're going to see here, I also have this factory method here that I'm calling from birth year. And the idea here is what I actually want to do is I want to be, let's say I don't want to have to calculate and do the math on, how old somebody is. But if I happen to know what year they were born, I want to be able to pass that in and then it will sort of modify the construction with that. And you're going to see here, what happens here is you're going to see from birth year, it takes in class as a thing. And then what returns is an implementation of that class. So in this case, it'll be person with the name that's passed in and the difference between today's year minus your birth year as being your age. Now, by the way, there's actually some interesting edge cases with this. Just out of curiosity, can anybody think about why this is not a great idea for a function? Because, like, I mean, it makes sense. If I was born in, 2002, and obviously it's 2005, then 2025, then well, my year should be, 23, right? Any reason why this isn't a good idea? Actually, never mind. It would still work. Sorry, I'm being an idiot. Because I was about to say, like, what if someone was born last century, and so you were born in like 97? But I realized the year would be four digits, so it'd be 1997. So 2025 minus 1997 would still work. So never mind, I'm an idiot. It's fine, it works. Right, so here's the interesting thing. So again, what this class method does is it's essentially going to invoke, it's essentially going to execute the person class, and it's going to input, it's going to pass through the name as a parameter, but it's going to calculate the person's age by taking, the current year minus whatever their birth year is that you pass in. So then if you see how it then gets executed, so you're going to see here, right? So again, remember, I can still create it normally. I can still create a person, just pass an Adam who's 19 years old and display that. But I can also execute this from birth year thing. And by the way, notice that rather than it being the person object, I'm calling the person class, right? You'll notice here, again, class person, I do class dot class method, pass in John in 1985. It then executes the factory method that returns, again, executes person, name, and then whatever the difference is between, 1985 and today. And then, well, I guess that would be 40. Yeah. Well, 40. Yeah, yeah. 40. And then, right, and then I can do the object level thing for it. So this is an example here of a factory method. So question on this? And by the way, we will do an example of this to our own little class just to kind of cement this idea. But all right, you guys wanna do like a quick little thing? All right, so let's just kind of just go back to the no here. So again here, so game is League of Legends. So let's just make a very simple setter for the class level method for this. So I'm just going to do so again I'm going to do the at class method, new line, and I'm going to say actually yes, that's exactly what I was going to do. Def so I'm going to call this change game, and again put in class as an input, right? Not self. And then my input parameter, yeah, I'll just call it new game, sure. It's going to be, and then just update my class level attribute here, game, to be whatever my input is. So again, if I execute this, so right now, again, if I do player dot game, it's League of Legends, right? But if I do player dot change game and change it to Valorant, and now I update it, and it's Valorant. And note, right, tonight, even though we have all these code blocks, I have never created an object, right? There are no players tonight. If you look at my thing here, I have no objects in my environment. All I've done is created this class. But again, never initialized any objects of it. So everything that we've done right now has been at the class level. All right. How you guys feeling about this so far? You guys good? Have I lost you? You still with me? Yes, Berlin, great question. It is a reserved word, much like self in this instance is a reserved word, right? Self is what tethers it to the specific object, right? Even though we haven't defined the specific object yet, the mere fact that we have the self says whatever the object ends up being, that's what gets tethered to it. CLS does the exact same thing. That's what then allows us to change, CLS.game equals new game. That's what then allows us to modify player.game because it's what tethers um, whatever the specific class attribute is to that. So yes, it is a reserved word. Yeah, great catch. Okay. And Berland, I did want to go back to your question. So Berland, so you had the question early on of like, why is this useful?
Yeah.
Yeah. So now I think we're equipped to talk about this a little bit more effectively than we did earlier. Because there's two ways of thinking about this. Because when I talked about decorators, I talked about basically the ability to wrap functions, right? The ability to extend functions. And that sort of makes sense, right? Because And in this instance here, we sort of have that because if I want to, I could just execute get number and it'll just return 5. But if I wanted this expanded functionality, I could then, right, implement this, increase number, pass and get number, and get all that wrapped functionality, that extended functionality. So in this case, I quote unquote have my cake and eat it too, right? I have my root function that I can execute whenever I want, but I also have the ability to extend it, to wrap it whenever I want to. The interesting thing is what happens here. Because here, when I've decorated this function here, if I just execute get number, I don't get the original function anymore, right? I only get the decorated function. And so that kind of begs the question, okay, well, why am I going through all that hassle? Um, what's the value of doing that? And so what I wanted to demonstrate here is this idea here. Because the idea here is, in this instance, for instance, we would never, we would only ever want to execute from birth year as a class method, right? It's designed to be a class method. There's no situation in which we would just want to execute this as an object level thing. But because we can't just define it out the gate as a class method, we have to do this decorating in order to convert it into a class method. So we have to be able to do that. And so this gives us the ability to say, look, I only ever want from birth year to be a class method, but I need a nice, concise way of doing that that isn't kind of this messy way of creating the function, passing it through into the class method, storing the result, executing that result, right? Getting that. So in scenarios in which I would only ever want to execute a particular method as the decorated thing, but given the nature of the decorating, I couldn't just sort of define it by itself, right? I mean, the difference I think with this one is you could have just obviously done, like there was no need for me to do get number as a separate thing from this. I could have just done this as one code block. Like there was no need for me to extend it, right? But here there is a need for me to extend it because I cannot trivially sort of execute this class level thing here as a function call, but then somehow wrap that within something else, right? So I need that decorator functionality. So that's why this becomes so useful.
Yeah, it's getting clear because of the one you define the wrapper, decorator, and the decorated function.
Mm,
Yeah, it becomes clear.
okay, perfect. Yeah,
Yeah.
I hope so. I
And
think, again, I think the takeaway method from this is this idea that, um, right, this
so
no
this one, the CLS is more on the class level, right?
correct,
Yeah,
exactly.
and the self is more on the instance of the object.
Yes, exactly,
Okay. Mm.
exactly. And because we would only ever execute this on the class method, we would never do from birth year as an object level thing. It has to be a class one. We would only ever execute it as a decorated method. And so because of that, using this concise notation that sort of permanently decorates it is what gives us the ability to kind of write out the syntax to do this and then just kind of wrap it in a class method and it automatically becomes a class method.
Got it. Thank you, Prof.
Okay, perfect. So again, so we sort of see here again class methods, right? Class methods, again, generally speaking, they either modify attributes at the class level or they're factory methods that then sort of modify input parameters to the class constructor such that when it creates an object, it specifies it, right? This is what that example here is looking at here. So in this case, I don't have to calculate age separately. I can just pass in birth here, but by invoking this class method, it will create an object with the right information, name and age, but it'll do the necessary conversion prior to executing it. So those are class methods. Where are we here? Okay. So static methods. So again, so static method is methods that exist within a class, but they don't interact directly with any element of that class. And you might say, um, And again, another way of saying it, it's bound to an overall class rather than any objects of that class, any specific objects or class level attributes of it. And again, well, oftentimes we talk about this as being sort of a utility function. It's things that are useful and can be replicated within a method. Um, but they don't necessarily directly interact with it. And so here's a good example of this that I think will help to sort of illustrate this. In this case, we're going to create a static method here called add numbers. And you're going to see here, unlike the calculator class that we did, I think it was your final exam. Do you guys remember one of the final exam problems in Intro to Python actually had you do a calculator class? And you may remember for that one, you had a constructor with one parameter, and that was whatever the end value was. And then you had a bunch of methods, and those methods were about modifying that parameter, that attribute. So here in this case, what you'll see here is that it's not modifying any object level parameter, right? In this case, add numbers just takes in two inputs and returns the sum of them. So there's no attribute that it's modifying, but it's useful to organize it under calculator, right? Because you could very easily imagine, wanting to create a calculator class and then just having a bunch of, again, utility methods for adding, subtracting, multiplying, dividing, right? Doing all those things. But because we don't, need to modify a parameter, an attribute for it, we don't need to instantiate this class. So, so again, and by the way, again, you'll see the exact same thing here, right? In this case, this starts off as an object level method. You would have to pass in the static method to then sort of create a, again, a decorated static method thing. But you can see, or you can do this shorthand here. Just like they add, ampersand class method, you just do an add static method, just do that, and then it works. So same basic idea here. But, again, so in this case, we can sort of create an overall calculator class. We don't need to create any objects for it. We just create all the utility functions, just take in the numbers, do the math, and then whenever you want to execute it, you just execute it directly. In this case, right, calculator, add numbers, and just adds it for you. So again, it's sort of a really, really nice organizing principle of effectively sort of a really nice way of essentially creating kind of a library of utility functions for it. Yeah, let's just do kind of a quick, let's just do kind of a quick static method for us. So here, let's see. Oh no, that's not ours. This is ours here. So let me add a static method. I'm just gonna do. I'll do like a game status method, right? Because if the game is over, if the overall game is working, so I'm going to say at static method def game status. In this case, I'm not going to have any, I don't think I've taken any input parameters for this, right? No, I don't think I need to because I don't need to reference the class. Yeah, so I'm just going to print. Game is, yeah, I don't even need to reference. I'm going to say print. So here again, really basic thing here. Just when you check it, like, is the game running or not, it'll just tell you game is active, right? So again, let me just kind of do this here. Again, no game objects, but I can just say player, again, class reference, player.game status, and I'll tell you game is currently active. So, and again, this is, this is a concept that, you will see, it's interesting, like in Java, you will see that like, whenever we need to create any sort of functional programming, like we literally, everything has to be wrapped in a class. Like if we need to just do like a main method, like just a general method, we have to wrap it within a class and then we just define it as a static method. It's just a keyword, static. Oftentimes we even just do a static void method. So we'll say like we don't have an explicit return with this, but like we have to wrap it within that parameter if we want even just basic functionality. in our um, in our programs, we kind of have to do this. So it's both a blessing and a curse because again, within programming languages like that, it's very explicit that everything is there and everything is kind of shoehorned to that. Python came along and said, hey, everything doesn't have to be a static method of a class. Like that's kind of unnecessary. But precisely because they kind of untethered that, if we did want that functionality, we now have to go back and we have to kind of do this decorating thing to kind of reintroduce it into it. So there's sort of an interesting, I guess, dynamic there. And if you take those two programming languages, hopefully it'll be kind of interesting to sort of compare and contrast those as you look at that. So, summing it all up again, static versus class methods. Um, you know, again, this is talking about methods that are not at the object level, but these are methods that impact the overall class level. So it has to be turned into a class method. Um, the class method generally will take CLS as its first parameter because it's modifying the overall class. Static method needs no specific parameters. A class method can access and modify the class state, as well as associate class level attributes. While in contrast, a static method cannot access or modify class level attributes. And so again, in general, static methods know nothing about the overall class state, right? They sort of, again, you can just think they're utility functions. They exist. It's a library of functions that again can be useful to organize. It's sort of nice. You can sort of like import the calculator class and then run all these methods. Um, but you don't need to, but these are inherently static methods, right? You don't need to create specific objects or things like that to get them to work. But in contrast, again, class methods, right? They're generally either factory methods, like we saw, that modify how sort of objects of that class are created by executing that class, or they access, or they're getters or setters for class level attributes. All right, so yeah, so that's that in a nutshell. Questions? All right, so let me check in with you guys because, like I said, there is one more topic that we need to cover for object-oriented programming, and that's encapsulation. I'm kind of a mindset that we covered a lot tonight, and I don't know that I want to start a brand new topic right now. So I'm of a mindset to say, let's talk a little bit about Lab 3 and specifically about the areas around decorators and class and static level methods, and we'll call that a night. But if you guys were really, really inclined, we could push on and start a whole brand new topic. Um, but you tell me how you guys are feeling. Okay, I'm getting one vote to hold on the new topic. Okay. Yeah, I figured as much. This was a lot. Yeah. I uh I kind of agree. Yeah, this was you guys had to slog through quite a lot to get here. Okay, so let's punt on this. We'll do this next week. And that's good, honestly, because I'd rather not like force this. Because encapsulation is in its own right a really fascinating topic, and I'd rather like we come at it like refreshed and open-minded and just kind of have the ability to talk it through rather than kind of force it because yeah we'd be forcing it right now and that's not great for anybody and it is a really cool topic so I do want to make sure we do it justice so okay good all right I think we're all in agreement on that so again this week you have another lab. It's another sort of collab based lab where you have a series of exercises. Not a whole lot to sort of note here. So again, you are going to practice some decorators. So in this case, you're going to create sort of a basic function here. I create a function meatball that takes in no inputs, but simply prints, I lost my poor meatball when somebody sneezed. If you have any guesses as to what I've been listening to a lot lately, um, then you're going to define, that should be a decorator function, sorry. um, spaghetti that takes in a function and then will, as an input, and then prints on top of spaghetti all covered in cheese, ends on the line that, and then invokes the function to complete the song. And then finally decorate meatball with the spaghetti wrapper function. Okay? So again, so you have your basic meatball that prints out less my poor meatball. You create a decorator function. In fact, let me just say, because I messed up on that decorator function. Okay, we go. Let's just make sure we're using the right syntax for that. Okay, so that's gonna be the first thing we're doing. Again, really basic stuff. Okay, no, I don't want to. I don't want to. What? What happened here? I didn't want to create a copy. Oh, whatever. Okay, I'm not sure what just happened there. Whatever. Okay, so now, so that doesn't have any parameters. So now modify your meatball function to take in an input food that modifies the output string. I lost my poor food when somebody sneezed, and then modify your wrapper function. So that's the function within the decorator to take in a flexible amount of arguments. So to take in args, right? Okay. So now furthermore, then I'm going to ask you to modify your previous meatball wrap function to be a class method for a class song. So I should be able to create, so in other words, right, so take that kind of decorated function, and now I should be able to create a song object and then invoke object meatball method to handle individual food items. So in this case, you can sort of see here, I create pizza, I then invoke pizza, the pizza method, and then right, it should work. So that's going to be the sort of the first three things. So again, you're going to be asked to create a basic decorator, modify your decorator to take in inputs, then wrap that within a class, your decorated function within a class. So we're not talking class versus static methods. It's still a static method, but it's it's still an object level method, but it's an object level method. It's a decorated object level method. Whew, right? Like in this case, pizza is an object of the song class, and then you're just invoking meatball, which again is an object level method that is decorated. All right, so far so good, hopefully. Okay, cool. And again, my hope is that this should pretty much reflect the work we've done is my hope with this. So now we're going to look at static versus class methods. So now you're going to define a class, math utils. So math utilities, that includes a static method add and adds two numbers, x and y together and returns the result. Okay, so right, pretty much what we've sort of talked about. You're going to create this class math utilities. You're going to create a static method for it. You're going to decorate it as a static method. It'll be add and it'll take in those two inputs and modify them. So, right, that should be pretty basic. I mean, pretty much along the lines of what we've sort of already done directly. Now, I want you to create a class level method. So I said they often use as alternate constructors or to access or modify class level attributes. So first, create a class customer. So customer will have a class level attribute called count, which will be initialized to 0. And it will have a constructor that defines an object attribute name and based on an input and also increments the customer count by 1. So here's kind of an interesting idea with this. I thought this was kind of a cool idea here. Um, and I even mentioned this, the idea behind this is that every time an object of the class is constructed, the overall count goes up by 1. Okay, so yeah, so again, so this is going to be this is going to be sort of, you can think about this as like a factory method, because the idea here is that I'm creating a specific object, I'm creating the customer object, but I'm also every time I'm creating that object, I'm also incrementing this class level object. In this case, right, I'm keeping track of how often a customer is created this way. And then, and so that's basically sort of a factory method. So then I'm going to do a getter method for this. So this get count method we'll again use the class method decorator. This will take in the class itself and then allow you to access class variables and then return that count attribute. So in this case, I want to be able um, to uh, be able to see again the number of customers that have been created. So like you can see here, in this case, I create two objects, specifically two customers, and then I get the count, and it should output to two. So yeah, so I hope that's kind of a cool example of, you know, it's both like this first one's it's both a right, it's both a factory method because again, we're ultimately using it to generate these, but it's also a setter because in addition to doing that, you're also modifying a class level attribute, and then you just get a getter for that class level attribute. So, any question on those exercises for lab 3? Again, hopefully that should be, like I said, my goal with all these is never, they should hopefully reinforce everything we've been talking about. They shouldn't be too much of a stretch, an extension for you guys. I hope it should be fun to play around with. And again, don't worry about any of the encapsulation stuff. That is all for next week. So, all right, crew, that's all I got for tonight. Any parting questions? Yeah, and thank you. And guys, thank you so much for hanging on. I know tonight was not the easiest material, so I really do appreciate you sticking with it. All right, I'm going to end on that note.